So, today we will be solving your JEE paper PO2 dated 8th July 2023. So we go to the first question. A ray of light of intensity I is incident on a parallel glass slab at point at the point A. So then and it undergoes partial reflection and refraction as shown in figure. At each reflection, 25% of the incident energy is reflected and the rest is transmitted. Right? This is important. 25%. Right? Then if the rays AB and A dash B dash, means AB is this, A dash B dash is this, A dash B dash, undergo interference, then the ratio of Imax by Imin is. So what will be the Imax and Imin? So what will be Imax Imin? First we will see what are their intensities. So if this is I, they have told this is I. So 25% will get reflected, huh? So this will be I by 4 at this point. This will be the reflection. We have done this in the class. This will be 3 I by 4. Then here again it is reflecting. So 25% of this will get reflected, right? That is 1 by 4 of 3I by 4, which is 3I by 8. Then again here reflection is happening. So here if you see, this is refracted and this is reflected part, the reflected reflected ray. This is refracted ray. So refracted ray is 75% of the incident, and this is 25. So 75% is 3 by 4 of 3I by 8, which is 9I by 8 for the 32. 9I by 32. Right? So now I by 4 and 9I by 32 are interfering. Imax and Imin. So Imax will be, you know this formula. Imax is A1 plus A2 whole square. Right? Oh, sorry. 3I by 16 actually. Right? So 16 power 64. So it's from 64 actually. Right? 3I by 16. 3 by 4 of 3I by 16. So this is Imax by Imin is A1 by A1 plus A2 whole square A1 minus A2 whole square, correct? Maximum amplitude is A1 plus A2, minimum amplitude is A1 minus A2, and intensity means square of amplitude. So this will become individual root I1 plus root I2, because I is proportional to A square, by root I1 minus root I2 whole square, correct? So this will be, if you see I by 4 and 9I by 4 and 9I by 64 are there. So if you do root, what will you get? 1 by 2 plus 3 by 64 is 8 square, 8 square root. So 1 by 2 minus 3 by 8 and whole square is there. I and I will get cancelled. I square will cancel. Sorry, I will cancel. Then 1 by 2 plus 3 by 8 is into 4 divided by 4, 4 by 8, 7 by 8. And here it will be 4 minus 3, 1. So 7 by 1 you will get 7 square by 1 square. You will get 49:1. Option D. Okay, we'll go to next class. Next option. Next question is, next double-slit experiment, the ratio of intensities of a bright band and dark band is 16:1. The ratio of amplitude of interfering waves will be same thing again. This is Imax, this is Imin, and dark band means. So Imax by Imin is ratio of amplitude they are asking. So Imax by Imin is A1 plus A2 whole square divided by A1 minus A2 whole square. This is 16:1, right? 4:1. A1 plus A2 divided by A1 minus A2 will be 4:1. So here you take this side, you will get A1 plus A2 is equal to 4A1 minus 4A2. So take this side, 5A2 and 3E1. So it is 5:3. Then the Young's double slit experiment, third question, Young's double slit experiment, the distance between slits and screen is 1 meter. So this is your capital D. And monochromatic light of wavelength 600 nanometer lambda. The person standing near the slits is looking at the fringe pattern. Okay. When the separation between the slits is varied, interference pattern disappears for a particular distance d0 between the slits. If the angular resolution of the eye is 1/60 degree, then the value of d0 is close to. So this, if you see, a person is there. This is a double slit experiment. The person is there near the slits. Okay? He is near the slits only. Almost here you can tell he is near the slits. And here, what? Here you are getting patterns. But he is. It is told that he is not visible. It is not visible only. And so when this will happen? When this is central bright fringe, है ना? And this is dark fringe. This is also dark fringe. First dark. So if suppose this is your central bright, this is your central bright. Okay? This is your central bright, and here you have dark, and here you have dark, and he is seeing from here. If he sees this dark and this dark, if this angle is less than angle of resolution, which is given here, this angle is less than angle of resolution, then he will see these two to be joined together, hai na? So he will see darkness only everywhere. So that's why he will not be able to see anything. So if you see, this will be equal to beta, 1 fringe width, and this distance will be approximately d, and this will be your theta. So if you see L is equal to r theta, if you apply here approximately, you will get beta is equal to L is equal to r theta, beta is equal to d theta, correct? L is equal to r theta. So here theta is your resolution, angle of resolution of eye, and d is given. Beta is lambda d by d. Lambda is also given. That you will get by asking d naught. Okay. So here if you see theta depends on d also. You see beta is equal to lambda d by d is equal to d into theta. Dt cancel. So theta is equal to lambda by d. So theta depends on lambda and d. So this different distance between the slits. So they are telling at some particular d, theta becomes means interference pattern disappears. It means theta becomes equal to angle of resolution less than this, or at least this much. So what will be that d naught? So if you solve, you will get 1 by here theta to be taken in radians, right? So 1 by 60 degrees there. It will be 2 pi into 2 pi divided by 180, right? These many radians. This will be theta is equal to lambda. Lambda is 600 into 10 power minus 9 by d naught. So we'll get d naught as, solve this. So we'll get d naught. So d naught will be equal to d naught will be equal to 600 into 10 to the power minus 9 divided by here into 180 into 60 divided by 2 pi. So what will get if you solve it? They are close to, so approximately little bit. Pi can be taken as 3 and 3.14 it can be taken as 3. 2 3 is 6. So 6 ones and 100. So then here also 1 0 we have, 3 zeros we have. 10 power minus 6 we will get. So, and 180 is there. 10 power minus 5 we will get. And 18 is the 108. 120 into 10 power minus 5. Right? is in meter. So if you want, then if you write 10 power minus 2 will remain. This is 100. This is 10 power minus 2. So 1 Option A. Option A. Okay, wait. Options. It's not option A. Option C actually. Okay. Calculation mistake. This is 2 pi by 180. Okay. This should be 1 pi by 180 actually. And this 2 should not come actually. We are converting. So this 2 I will remove from everywhere. D naught. And this 2 was here actually. So 1s are 200. So 2 will remain there. So in my answer 2 will come. So 2 mm. Option C. Okay. So then we'll go for fourth question. What is fourth question? When the angle of incidence on a transparent material is 60 degrees, the reflected ray is completely polarized. It means it is Brewster's angle. The velocity of refracted ray inside the material is. So this is Brewster's angle. Tan IB is equal to mu. Correct. So from here you will get mu. So take that mu. Tan 60 is root 3. So mu is equal to root 3. So velocity of refracted ray is mu is equal to, or n is equal to c by v. So this is velocity of light in vacuum by, so this is 3 into 10 power 8 by root 3. We will get root 3. Okay. Which is option B. So we will go ahead. Fifth question. So assuming that the human pupil has a radius of 0.2 centimeter and a comfortable viewing distance of 25, the minimum separation between 2 point objects with the human eye can resolve for the wavelength of is. So we see human eye is a lens, right? We will see. A human eye is just a human lens is just a concave lens, convex lens, right? It just acts like a simple microscope. So for simple microscope, we had this resolving power. Theta is equal to 1 point, or d theta is equal to 1.22 lambda by d, where d is aperture diameter. We are given radius of the pupil. So diameter will be 2 times of that, and lambda is given as 500. So we'll get d theta from that, from this formula. So this will be your d theta. But they have asked for minimum separation between the point objects that the human eye can resolve. So they have asked this actually. This x they have asked. So okay, sorry, this will repeat actually. Okay. These two are the objects. This will be theta actually. This is theta. Theta is 1.22 lambda by d. So we get this theta. They want this x actually, or this distance they want, and this distance is given. It is comfortable weaving is 25 centimeter. So now L is equal to if you apply, it will become 25 is equal to R is x. Sorry. This is L actually for this arc. If you approximate it to R, L is equal to R 25 into theta. This is centimeter, okay, into theta. Theta is 1.22 lambda by d. So this is in centimeter, and this is also in this will also come in centimeter. Centimeter cancel. So this is nanometer. Okay, accordingly you see the units also. So you will get 30 micrometer from that. Okay. Then sixth, first diffraction minimum due to a single slit of width is at 30 degree, the wavelength of the light is. So this is single slit experiment, first diffraction minimum, है ना? So first minimum where you get in diffraction experiment, you will get it theta is equal to lambda by a, right? A theta is equal to lambda by a, है ना? They are telling this is 30 degree. So 30 degree means you cannot just approximate like that. This is sine theta. A sin theta is equal to lambda, right? Path difference is equal to lambda. Path difference is a sin theta. So sin 30 is 1 by 2. 1 by 2 is equal to lambda we have to find. A is 10 power minus 4 centimeter, 10 power minus 6 meter. So it will go that side. It will become 0.5 into 10 power minus 6, that is 5 into 10 power minus 7. So 5000 angstrom. Okay. Then we go ahead 7000. So a point source here emitting light of wavelength 600 nanometer is placed at a very small height h above a flat reflecting surface AB. Here this is reflecting surface. The intensity of reflected light is 36% of the incident intensity. Okay. Interference fringes are observed on a screen placed parallel to the reflecting surface at a very large distance from it, at a very large distance d from it. The intensity at point P corresponds to a maximum, then the minimum distance through which the reflecting surface AB should be shifted so that the intensity at P again becomes maximum is given by. Okay, we have to shift this. In ZP we are getting maximum, means path difference is integral multiples of lambda, right? From here one wave is coming from source, many this point source, na? So many waves will be coming. So from here one wave will be coming, one wave will be going like this. It will reflect and go back like this. So this wave is straight only. This wave and this wave both interfere to give you maximum here. Now they are telling how much you should take it down, shift it. Right? Suppose you shifted it like this down by X amount. Okay. So how much this X should be, so that again you get here minimum distance through which you have to shift it, so that you again get maximum here. So when that will happen, when path difference now is some n lambda. So now if you shift again, it should be n lambda only. And what is the minimum thing that can happen? Path difference can increase by lambda. Then again you will get bright fringe only. Again it will be constrict interference only. If again some lambda gets increased path difference. So if you see, if you shift by x, this will go as if it is going, but this will come. Earlier it was having this much path only, but now it will cover this much path plus again this much plus. So it will cover 2x path more. So 2x should be equal to lambda, minimum thing which can happen. So x is equal to lambda by 2. Lambda is 600 nanometer. So our answer is 600 by 2, that is 300 nanometer. Okay. 7th is A. We'll go ahead. Then a parallel beam of monochromatic light falls normally on a single narrow slit. How does the angular width of principal maximum in the resultant reflection pattern vary with the width of the slit? Right. So this is a single slit experiment. And angular width of principal maximum. Hai? So how much is that principal maximum angular width in single slit diffraction? If you see, and this will be at theta is equal to lambda by a, our first dark fringe, and here also at theta is equal to lambda by a. So this will be our central bright. So angular width will be 2 lambda by a, right? This is lambda by, this is lambda by a. This will be angular width. So if so angular width will increase if this decreases. So increase on increasing, no. Decrease on decreasing, no. Increase on decreasing, correct. Width is C. And we'll go for 9th question. Then two coherent sources. Two coherent sources S1 and S2 are separated by a small distance d as shown in the figure. The fringes obtained on the screen will be semicircles, points, concentric circles. Okay, this one. See here now what will happen. If you take like this one and like this one, so this path difference, whatever is the path difference in this case, if you go circular way like this, out of the plane like this, circular way if you go, it's like you hold these two and just rotate them. What will get? A circle will get. है ना? Like this in 3D will get a circle. So all these points will have same path difference, correct? At all these points, they have same path difference. So either you are getting constructive interference or destructive interference, it will be in circles. Then bright, dark, bright, dark, bright, dark. You will get concentric circles. You can imagine. Right? So not be semicircle, it will not be point, it will not be straight line. Right? Because in straight line, if you go, path difference varies. Right? You take two waves and interfere them and go along the line. You will see path difference will vary. Now the interference, 10th question, the interference pattern is observed at P due to superposition of two rays coming out from a source as shown in the figure. Okay. Okay, this we have done in the class actually. Huh? The value of L for which maxima is obtained at P is R is a perfect reflecting surface. So from S also the wave is coming. From S is the source. So one ray is going like this, one ray is going like this, which is getting reflected and coming here, and here it is interfering. So these two waves will interfere. What is the path difference that we have to see? Basically phase difference we have to see. For constructive interference, what should happen? So here one thing I had told is at reflection pi path difference, pi phase difference is added due to reflection. So it is not just corresponding to path difference. Pi phase difference is also included. Phase difference will be corresponding to path difference plus pi. So if I see according to path difference, if I consider here destructive interference, so destructive interference plus pi is lambda by 2. So lambda by 2, if you add, it will become constructive interference. So I will get path difference corresponding to destructive interference, but it will become constructive interference because of this pi introduction of phase difference due to reflection. And it will be like constructive interference. So for destructive interference, what should be the path difference? So first I will see what is the path difference. So path difference will be this path is 12. So this is okay. But this part is this path, correct? And how much will be this path? Path will be minus. Drop a perpendicular. This will be like this. This will be L. This will be L. This is 30 degrees, so this will be 30 degree. Then this is your hypotenuse. this is your adjacent. So cos 30 is equal to L by hypotenuse. So x is equal to L. This is root 3 by 2, 2L by root 3. So this is 12 by root 3. This will also be 12 by root 3, 4L by root 3. So 4L by root 3 is the path minus this path. So this is the path difference. So path difference should be equal to, here in path difference should be equal to odd multiples of lambda by 2. Then it will be for district interference, but they ask for constrict interference only, but this pi will also get added. So path difference will create a case for district interference, but because of this reflection, it will become construct. So this will be, so L is equal to what they have asked. So in the options, odd multiples, 2n plus 1 or 2n minus 1 I can write, but 2n minus 1 is there in the option, so I will write 2n minus 1. So L will be equal to, now it is, we can solve now, by 2. This will be 4 minus 2 root 3 by root 3. So root 3 will go up, 4 minus 2 root 3 will be minus. So it will be 2, if you take common, it will become B option. Right. So we'll go ahead. And found offer diffraction experiment in the single slit using light of wavelength 400 nanometer. The first minimum is formed at an angle 30 degrees, and the total number of maxima which can be observed on an infinitely large screen is. This is diffraction experiment, है ना? They are telling first minimum is formed at 30 degree, है ना? So first minimum forms at what? A sin theta is path difference, है ना? In diffraction, this path difference. So first minimum is path difference is lambda. So this is at 30 degree. So what will get? A sin 30 is equal to lambda is 400 nanometer. Sin 30 is 1 by 2. So A is equal to 800 nanometer. And now they are asking in total number of maximum which can be observed on infinitely large screen. So screen length has no limit, but how many maxima will be there? है ना? So if you see, this is path difference, है ना, in diffraction, and for maxima path difference is equal to odd multiples. N is equal to 1. If you put, you will get 1 lambda by 2. Okay. So this is the condition for maxima in diffraction. So asking how many can come. So basically they are asking how many n's you will get, है ना, number of maxima. So A is 800. Okay, basically it is lambda, like lambda 1 by 2, 2 lambda basically. A is 2 lambda. From here you can get 1 by 2, 2 lambda. So 2 lambda into sine theta is equal to 2n minus 1 into by 2 into lambda. Lambda will cancel. So now if you see n and sine theta are there, they are proportional here. Right? So n's maximum value is when sine theta has maximum value. Sine theta maximum value is 1. So you keep it 2 into 1, 2n minus 1 by 2. This will become 4. 4 plus 1, 5. 5 by 2 will get. N is equal to 5 by 2. So sine theta, okay, sine theta, if you see, it will become sine theta is equal to 2n minus 1 divided by 4, it will become. Sine theta is always less than or equal to 1. So n will get, you will get like this. N is less than or equal to 5 by 2. That is 2.5. So n in diffraction pattern, if you see, n is equal to 0 is possible, n equal to 1 is possible, n equal to 2 is possible, n equal to 3 not possible. It is less than 2.5. N is equal to minus 1, n equal to minus 2 is possible. So beyond that, no, right? So 5 maximas are possible. Total number of maxima are 5. Okay. One count actually. And that is 1 by 2, 2 lambda, 2 lambda. So n is equal to 1 if you put 2 minus 1 is 1 into lambda by 2, 1 lambda by 2. Okay. So n starts from 1 actually, है ना, if you take like this, because n equal to 0 if you put, you will get -1, which is not the case. So here it starts from 2, here it becomes 2n plus 1. N equal to 0 if you put, 1 lambda by 2 will get, right? Plus 1, 4 minus 1, 3. So we'll get 3 by 2 actually. N will be less than or equal to 1.5. So n equal to 1 is possible, n equal to -1 is possible, and n equal to 0 is your central maxima. But n equal to 0 corresponding, there is nothing actually. It's only that everybody will come like this. There is 3 actually. This is the mistake, 2n. Okay, we'll go ahead. Mm, 13th question. This 12th question. This 12th question we will do later. The option D is the correct answer. I'll tell you later. Then positive point charge. Okay, this is electrostatics. Okay, then we'll go for section B. Names double-slit experiment using monochromatic light of wavelength lambda. Intensity of light at a point on the screen with the path reference lambda is m units, and the intensity of light at a point where the path reference lambda by 3 is nm. What is the value of n? How to do this? In double-slit experiment, this is. And so where path reference is lambda, you will get a bright fringe. And so m is actually 4I0, right? And intensity of where path reference is lambda by 3. So lambda by 3 path difference, how much intensity will get? So intensity, resulting intensity is 4I0 cos square 5 by 2. So lambda by 3 is path difference. So phase difference will be how much? Wherever lambda is there, put pi, 2 pi. 2 pi by 3 will be the phase difference. Put that here. It will be 4I0. 4I0 is m. Okay, capital M. Cos square 2 pi by 3 by 2 is pi by 3. Pi by 3 is 60 degree. So cos square 60 degree. Cos 60 is cos 60 is 1 by 2. So it is m by 4. So it is m by 4. So I is equal to nm they have given. So mm cancel, n is equal to 1 by 4. That is 0.25. So n is 0.25. And we will go ahead. 22nd problem. In a special arrangement of having double-slit experiment, the distance between the slits D is twice. Okay, so D is twice the distance between screen and slits D. That is D is equal to 2D. Okay, this is given. For this setup, the value of D such that the minima on the screen fall at a distance D from the center. Okay, this will be the minima. This will be dark fringe, right? Or minima, dark fringe at a distance D from the center O. This will be also D. Is found to be lambda by n. Okay, so this is lambda by n. Lambda is wavelength of light used. Value of n is okay. So this will be also D fully. This is also D. That and this is minima, and this is Einstein double-slit experiment. So if you see, and this is actually small d, in which d small d is 2 into d. So this will be d, and this will be also d, and this is also d. So this will also be d. Telling here minima is there. So for minima, if you come like this will be one path, and from this also one wave will come, its path will be like this. So path reference between these two, this is the first minima. So path difference between these two should be lambda by 2, first difference, first minima. So path difference should be lambda by 2. So what is the path difference? See, this is the D. Okay, this is 2D and this is D. So this is right angle. So this will be Pythagoras theorem. Root of 2D means 4D square plus D square. That is root of 5D square. That is root of 5 into D. This will be this distance S2P. S1P is D. Path reference is S2P minus S1P, which is root 5D minus D. That is root 5 minus 1 into D. This is the path reference. And for first minima, this path reference should be lambda by 2. And D is given as lambda by N. Equal lambda by 2. And root 5 value is given 2.24. That will be 2.24 minus 1, 1.24. Right? Lambda cancel. N they have asked. N is equal to 2 into 2.4. That is, 2 into 1.24. That is 2.48. 2.48. Okay. Then 23rd problem. YDS is conducted using light of wavelength 6000 angstrom to observe an interference pattern. Okay. When a film of some material 3 into 10 power minus 3 centimeter thick was placed over one of the slits, the fringe width shifted by distance equal to 10 fringe widths was verified. Okay, this shift problem. Shift we have discussed. How much will be the shift? U minus 1 into T into capital D by D. This much will be the shift. And this shift they are telling is equal to 10 fringe widths, means 10 beta. Beta is lambda D by D. So D, this cancel. So they are asking refractive index of the film. So mu minus 1 into thickness is given, I think, 3 into 10 power minus 3 centimeter, which will be minus 5 meter, is equal to 10 into lambda. Lambda is 6 into 10 power minus 7. So it will be 6 into 10 power minus 6. 6 into 10 power minus 6 divided by 3 into 10 power minus 5. 3 I will cancel here, 2. This will go up minus 1. So 2 into minus 1 is 0.2. Mu is equal to, this minus 1 is there, 1 plus 0.2, that is 1.2. So it will be 1.2. Okay. Then the ratio of 24th, the ratio of amplitudes of two coherent waves in a cell-based experiment is A1 by A2 is equal to 1 by 3. What is the ratio of maximum and minimum intensities of fringes? Okay. Yeah, we have discussed this many times now. Mx by Mn is A1 plus A2 whole square by A1 minus A2 whole square. So if you take it as A1 by A2 is equal to 1 by 3. If you take this as x, this will be 3x. So x plus 3x, 4x by 3x minus x, 2x. 4x by 2x. X square cancel, 4 square by 2 square. So 4 square is 16, 2 square is 4, 4 by 1. It is 4 is to 1. It is 4 is to 1. Then 25th problem. In any double-slit experiment, both the slits produce equal intensities on a screen. A 100% transparent thin film of refractive index is kept in front of one of the slits, due to which intensity at the point O on the screen becomes 75% of its initial value. Okay. If the wavelength of monochromatic light is 720 nanometer, then what is the minimum thickness of the film? Right? So here this is the double-slit experiment. So here now earlier 100%, sorry, here earlier, okay. Here earlier constructive interference used to happen, है ना, at the center. At the center it used to be constructive interference and intensity would have been 4 I naught. But now they are telling it is 75% of this, means 3 by 4 of this. That much intensity is there here now. It means it is not fully constructive interference or destructive interference. In between, some phase difference is there. So what is that phase difference between the waves which are interfering? And that is coming due to a thickness of something is introduced, correct? So so path difference was, earlier path difference was 0, but now path difference is introduced. Some path difference is introduced, which is equivalent to this phase difference. And so we will see for what phase difference this intensity will get. So 3 by 4 of 4 I naught is the new intensity, and intensity after interference is 4 I naught cos square 5 by 2. 4 I naught cancels. So cos square 5 by 2 is equal to 3 by 4. So it is root 3 by 2. Cos 5 by 2 is equal to root 3 by 2. Root 3 by 2 is cos 30, right? So phi is equal to 60 degree, correct? 5 by 2 is 30. Phi is equal to 60 degree. So phase difference of 60 degree has come. 60 degree is pi by 3. So phase difference of pi by 3 has come. So this is equivalent to path difference of path difference you want, right? So lambda is equivalent to 2 pi. Pi is equivalent to lambda by 2. So lambda by 2, if you put here, you will get lambda by 2 into 3, lambda by 6. So it is new path difference is lambda by 6. And actually path difference geometrically seeing it is 0, but this much path difference this is showing, it is because of this. And this introduces how much path difference? This introduces mu minus 1 into t path difference, correct? S2p minus, so this is S1p minus t plus mu. So mu minus 1 into t. S2p minus S1p plus path difference. Okay, here S1p is more, so I will take S1p minus S2. Then it will become minus plus minus S2. Become mu minus 1 into t. So mu minus 1 into t is lambda by 6. That much is introducing, right? They're asking minimum thickness. So t is equal to lambda is 720 nanometer. So they are asked in nanometer only, so I will keep its lambda nanometer like that only, by 6 into divided by mu minus 1. Mu minus 1 is, mu is 1.5 minus 1 is 0.5, that is 1 by 2. So 1 is 3 is 3 1 is 3 2 is 4 is 40, 240 nanometer, right? Then we'll go for next question, 26th problem. Okay, this was shown. So 26th. A beam of light consists of two wavelengths, 6300 angstrom and 5600 angstrom. This beam of light is used to obtain an interference pattern in amplification. If fourth fringe of 6300 angstrom coincides with nth dark fringe of 5600 angstrom from central line, then the value of n is okay. So fourth bright fringe. So both are coinciding. It means both are at same x, right? So this is 4 beta. No, not 4 beta. Position of bright fringe is n lambda d by d. And position of nth dark fringe is 1 minus 1 n is equal to 1. If you put, you will get 2 minus 1 and 2 lambda by 2 lambda by 2, Yeah. Yeah. So this will be your first direct, second direct like this. So now these two are same, x is same. So 4 into lambda d by d is fourth bright fringe is equal to nth dark fringe. Lambda d by d. Lambda d by d will cancel. Okay, lambda will not cancel. Lambdas are different. Okay, lambda 1 and lambda 2 will take. So it will be 4 into 6,300 is equal to 2 minus 2n minus 1 into 5,600, that is 56. 0, 0, 0, 0 cancel. Then 7 9 is 63, 7 8 is 56. So here 4 is there. 4 1 is 4 2 is. So we'll get 9 by 2. So 9 by 2 is equal to 2n minus 1. Okay, here by 2 is also there. This 2. It by 2. So this 2 and this 2 will get cancelled. 9 plus 1 is 10. 9 is equal to this 2 had cancelled actually. So 9 plus 1 is 10. 2n. N is equal to 5. So 26 is 5. Then we have 27th. And this 7th is in a standard Young's laboratory experiment, how many maxima can be obtained on a screen, including the distance between the slits is. We have just done this actually. Similar problem. So in laboratory experiment, path reference is d sin theta, correct? So d sin theta path reference, maxima they want. Path reference should be n lambda in Young's laboratory experiment. And then d is 5 lambda by 2 into sin theta is equal to n lambda, lambda cancel. So n is equal to 5 by 2 sin theta. They're asking maximum number of how many maximas will come. So sin theta's maximum value is 1. So n is less than or equal to, sin theta is less than or equal to 1. So n is less than or equal to 5 by 2, that is 2.5. So n is less than or equal to 2.5. So n equal to 0 is possible on the screen, n equal to 1 is possible, n equal to 2 is possible, n equal to 3 is not possible, minus 1 is possible, minus 2 is possible, minus 3 is not possible. So 5 are there. So 5 maximas are possible. Okay. So it's over. 28th is positive charge. Okay. 29th Q. Also charge 30 is also charge. Okay, so we'll end it here. Thank you. If you have any doubts, you can ask.